Okay, hello everyone. Welcome to today's presentation on delegates, lambdas, and events in C#. These are fundamental concepts that allow us to write more flexible and reusable code. Understanding them will help us handle callbacks, event handling, and functional programming in C#. In this session, we will break down these concepts step by step with simple explanation and example. So let's get started. Before diving into details, let's go over what we will cover in this session. First, we will start with delegates, which allow us to treat methods as variables. Then we will discuss lambdas expressions, a shorter and more readable way to write anonymous methods. Next, we will move to events, which are built on delegates and help us implement the observer pattern. And after that, we will explore common memory leak issues with events and how to prevent them. Finally, we will look at best practices to efficiently manage event subscription and avoid performance issues. So, what are delegates? Delegates in C# are special objects that hold references to methods. They allow us to treat methods as variables, meaning we can pass them as parameters, store them in variables, and call them dynamically. Imagine you have a TV remote. The remote doesn't know which TV it will control, but pressing the buttons triggers actions on the assigned TV. Delegates work the same way. They store method references and call them when needed. In this example, my delegate is a delegate type that takes a string parameter and returns void. And display message is a method that matches this delegate's signature. Here we create a delegate variable and assign it the display message method. Here we define a delegate using the delegate keyword, specifying its return type and parameters. This acts as a contract for any method we assign to it. And in this example, math operation is a delegate that takes two integers and returns an integer. A delegate is a type that holds a reference to a method. And before we can use it, we must instantiate the delegate by assigning it a method. This allows us to call methods indirectly, making our code more flexible. Delegates can reference both named methods and anonymous functions like lambdas. And this makes them useful for even handling callbacks and passing functions as parameters. In this example, we define a delegate called message delegate that takes a string parameter. Then we instantiate it by assigning it the method print message. So how it works, the delegate is defined to hold method with a string parameters, and we create an instance of the delegate and assign it the print message method. So by using delegates, we can pass methods as parameters, making our code more flexible and reusable. A delegate can hold multiple methods at once. When invoked, all assigned methods execute in order. In this example, on line 11, it adds method to the delegate, making it multicast. Let's talk about lambdas in C#. Lambdas are inline anonymous functions that simplify code. They are used with delegates, link, and functional programming. And in this code, you can see lambda expression. And this function represents a function that takes two integers and return an integer. Before lambdas, we used anonymous methods. And anonymous methods use delegate, but lambdas are shorter and cleaner. Lambda expressions provide a shorter and more readable way to define methods inside delegates. Instead of writing a separate method, we can use inline functions. This makes our code cleaner and more efficient. And lambdas work perfectly with delegate because they allow us to pass behavior as parameter in a concise way, and they are widely used in link, event handling, and functional programming in C#. In this example, we define a delegate math operation which takes two integers and returns an integer. Instead of writing a separate method, we use a lambda expression to define the behavior directly. So let's see how it works. The lambda expression replaces the need for a full method definition, and it assigns the behavior directly to the delegate in one line. Now let's talk about events in C#. Events are a powerful feature that allows objects to communicate in a loosely coupled way. They are built on top of delegates, but unlike regular delegates, events provide more controlled access, meaning subscribers can only attach or detach event handlers, but they cannot invoke the event themselves. Let's start with an example. Imagine you're organizing a conference and you want to notify all registered attendees when a session starts. Instead of manually calling each attendee, you create notification system where attendees subscribe to updates. When a session starts, a notification event is triggered and all subscribers receive an update. This is exactly how events work in C#. The object that triggers the event is called the publisher, and the object that listens for the event are called subscribers. The publisher defines an event, and when something happens, it notifies all subscribers. Events use delegates internally, and this means an event is like a delegate, but it's safer. We can add and remove event handlers. This example subscribes to an event and unsubscribes it later. Now that we understand how events work, let's talk about something critical when working with events. I mean memory leaks. Memory leaks in .NET are often caused when objects that should be garbage collected remain in memory because they are still being referenced somewhere. And one of the most common causes of memory leaks in .NET is event subscription that are not properly removed. Let's think about this in a real world scenarios. Imagine you are at a gym that allows members to subscribe to class notification, and when you join, you sign up for email updates about upcoming yoga classes, for example. However, if you move to another city but forget to unsubscribe, you will keep receiving those emails. And even though you no longer attend the gym. So the same thing happens in C#. If an object subscribes to an event but never unsubscribes, it remains in memory because the publisher still holds a reference to it, and the garbage collector cannot clean it up. In C#, one common cause of memory leaks is strong event references. When an object subscribes to an event, the event publisher holds a strong reference to the subscriber. And this means that even if the subscriber is no longer needed, the garbage collector cannot clean it up because it's still a reference. And about how events can cause memory leaks. In C Sharp, if we subscribe to an event but forget to unsubscribe, the event handler remains in memory even when the object is no longer needed. This prevents garbage collection and causes memory leaks. And the event publisher is still holds in a strong reference to the subscriber and keep it alive indefinitely. This is a common issue in long-running applications. So, to prevent memory leaks, we must always unsubscribe when the object is no longer in use. And in this example, the subscriber class subscribes to the something happened, for example, event, in the publisher class. And however, if we don't unsubscribe, the publisher will keep a reference to the subscriber and preventing it from being garbage collected. And let's talk about the solution. We add an unsubscribe method which removes the event handler, and this ensures that when the subscriber is no longer needed, it can be properly cleaned up. And let's talk about the first technique. In C Sharp, a strong reference keeps an object in memory as long as it's referenced. And however, if we use a weak reference, the object can still be garbage collected when needed. And this prevents memory leaks because the event subscriber won't be held in memory unnecessarily. And using weak references using a weak reference is useful when we want to reference an object without preventing its cleanup by the garbage collector. And here in this example, instead of holding a strong reference to publisher, we use a weak reference. And this means the publisher object can be garbage collected when it's no longer in use. So the weak reference allows the object to be collected when memory is needed. And one of the best ways to prevent memory leaks caused by events is explicitly unsubscribing when the object is no longer needed. And if we don't remove the event handler, the publisher holds a reference to the subscriber. So in this example, the subscriber class subscribes to the, for example, something event happened, event in the publisher class. If we don't unsubscribe, the publisher keeps a strong reference to subscriber. So what's the solution? We create an unsubscribe method that removes the event handler and sets publisher to null, ensuring the subscriber can be cleaned up properly. And remember, always unsubscribe in a dispose method or explicitly call an unsubscribe function. And let's talk about the third technique. In C Sharp, when an object is disposed, we should unsubscribe event handlers to prevent memory leaks. The dispose pattern ensures that objects clean up resources properly before they are removed from memory. And here in this example, the subscriber class implements iDisposable, meaning it can clean up resources before being garbage collected. And how it works, let's talk about how it works. When the subscriber is disposed, the dispose method unsubscribe from, for example, something happened. And this ensures that the publisher no longer holds a reference to subscriber. And in C#, the weak event pattern helps manage event subscription without causing memory leaks. But with this pattern, we use weak references, allowing objects to be collected when they are no longer needed. This is especially useful in long-lived applications, for example, like WPF. Instead of manual unsubscription, the system automatically cleans up event handlers. And it was the last slide. Now let's put all these together. In this session, we covered delegates, events, and memory management techniques in C#. And that was my presentation. Thank you all for your attention and have a great day. Goodbye all.